So welcome to the learning session on the upcoming trends with pharmaceuticals. This is being recorded, so if there's somebody within your organization that is not able to attend, we want to make sure that they're still able to get this information. So we will email this out to all of you, as well as some other people that had expressed interest that couldn't make it. So you're able to kind of learn from what we discussed today. Just housekeeping items, as if you're just new to the webinar, we will be able to take questions via the Q&A at the bottom of your screen. So if you do have questions or comments that you would like to make, please, Liz will be monitoring the Q&A. We'll make sure that your questions are answered. If not, what we will do is follow up after the webinar with questions. I'm John Monahan from PDCM. I think I know almost all of you. And then, of course, Liz DeJody from PDCM. I'm going to introduce the experts that are joining us today. Dr. Nate and Danielle, who are with MedOne. MedOne has been fantastic partners of PDCM and our clients for a number of years, specifically around being able to be ahead of the game, ahead of the trends, and help contain the ongoing challenge of the prescription drug costs. There are some significant changes happening to the prescription drug industry, and what we're finding more and more is our clients are looking to be able to understand the cost behind their prescriptions better, understand what they can do on their employees' behalf to enhance the prescription drug benefit, or also to contain the costs that are continuing to be a huge challenge. So MedOne is a partner that we have counted on to help us combat those changes. There are a few big changes and developments coming down the loop that you're going to be asked about. You might already be asked about, which is weight loss medications. And what does the future look like as people look at diabetic medications that are now being used for weight loss? Some biosimilar treatments that are coming out for very popular prescriptions that are high cost, such as Humira and Stelara and some of these others. As well as gene therapy prescriptions, where I had a discussion this week about around a drug that was over $2 million per year. So these are going to be big game changers in the prescription drug industry. That's coming around the corner. It's great that you're participating in this now to learn more about it. And I'll turn it over to you, Dr. Nate, and then I'll tune out and allow you to move forward with your presentation. Thanks for joining us.
Yeah, thank you, John and Liz and Kelsey for coordinating this and inviting me to come and share a little bit about what we're seeing in that prescription space. And as John teed it up, we're going to talk about weight loss medications and specifically the glucagon-like peptide 1 drugs like Ozempic that have really gained in popularity. We're also going to touch on gene therapy, kind of how we got to where we are today, a little bit of the evolution of that technology. And then we're also going to look at the new drugs that are coming to market and how that's kind of causing a whole new impact on payers that we historically have not seen at price points that we've just never experienced before. And then we're going to talk about those Humira biosimilars as well. So give me one quick second here. I'm going to share my screen and pull up our deck. All right, perfect. And then I'm going to rely on maybe my counterpart. Oh, let me switch that. There we go. Danielle, are you able to confirm for me if you can see the slide deck? Okay, perfect. Yeah, and then just by way of introduction, I'm Dr. Nate Harold. I'm a pharmacist and the Vice President of Clinical Services with MedOne Pharmacy Benefit Solutions. I'm a pharmacist by training. I oversee our clinical department as well as our pharmacy team that actually sends medications to patients coast to coast. I went to Iowa for pharmacy school. I then did my residency training out in the Pacific Northwest with the Franciscan Health System. I practiced emergency medicine for a few years, also covered ICU, critical care, and infectious disease service lines before switching over into managed care and relocating with my wife here to Dubuque, Iowa, where we're headquartered. and then have begun really a practice around population health and how can we make sure that our clients that are funding access to these medications are able to do so in a very cost-effective way, as well as members able to get the outcomes that they're seeking from these treatments. And then as such, I have the privilege of learning a lot about what happens with different trends in the industry. And then I really enjoy getting to take time to share those trends as well. And again, thank you to PDCM. They've been a great partner over the last several years, and happy to be able to come and educate on some of these topics. So we're going to start off just by talking about medication-assisted weight loss. And part of the problem that we're seeing in the prescription drug spend kind of year over year is this increase in overall allocation of resources into prescription drugs. That has not changed since I started in this role back 9 years ago. We continue to see that as employers look at their healthcare resource dollars, a greater percentage of that continues to be focused on the prescription drug space than what it used to be, where it was 10% up to 15%. Now we're seeing forecasts 20 to 30% of prescription drug spend, or sorry, of healthcare spend being focused on the prescription drug benefit. That allows us to really do some things, really focus in on what's driving that spend and what are ways that we can better manage that pool of resources. There's lots of factors that have caused that to occur. One is just the overutilization of a prescription drug benefit in general, and I use that term a little heavily. We in the United States are a little bit unique in how we think about access to healthcare. We're one of 2 countries that allows direct-to-consumer advertising, and there's a lot of disease states where the influence of that advertising really results in patients seeking out certain treatments and prescribers a willingness to write for those treatments, which causes overutilization, certainly of on-patent brand medications. There are times that we see underutilization, especially in certain disease states that are more silent in nature. But overall, we in the United States actually use medications more frequently than any other country in the world. And that part of that is because of the influence of direct-to-consumer advertising. Prescription drug price inflation is just an opportunity for a market to drive a lot of profitability. And the prescription drug market is one where they're able, due to really lack of regulation around prescription drug pricing, charge whatever they want to charge, and then have a system in place that really is there that supports funding of, in some cases, some pretty egregious prices. And then we have shifts in drug mix. Partly due to regulatory changes back in the 1990s to really incentivize the use of developing innovative treatments for rare disease states. That kind of created a situation where you see specialty drugs and orphan drugs being developed by manufacturers, where back in the 60s, 70s, 80s, that wasn't really the case. The manufacturers didn't feel like it was worth their while. But as those drugs come to market and we have treatments for conditions that we didn't have treatments before, that has resulted as well in increased expense to the prescription drug side. There's one other piece that's not on the slide, and that's really a shift in certain treatments that used to be given under the medical benefit or in a hospital setting that have now moved to a prescription treatment that can be done outpatient or in the patient's home. And so there's been a shift here, which we'll continue to see, where if we can manage patients successfully out of the hospital and they can manage their condition in the home, that's actually a good thing. It's a good thing for payers. It's a good thing for our healthcare system. Hospitals are not necessarily great places to get treatments if you don't need to get treatments in the hospital. But that's also resulted in a shift. And there's conditions that we used to have to manage in the hospital that now we can give patients just tablets and they can treat those same conditions outside of the hospital setting. And that's resulted in a bit of the shift over to the prescription drug side as well. More recently, as in from 2021, 2022, and into 2023, there's really 2 emerging drivers that we're going to talk about today. One are the GLP-1s. Those are the glucagon-like peptides that are approved for diabetes. They are also approved for weight loss, really through a lot of viral marketing. There's been increased demand of those products in ways that we had not historically seen. And then gene therapies, very expensive drugs coming in north. Some of the most expensive ones are north of $3.5 million. We have not seen those before impact our healthcare system, and we have to have different strategies in place to prioritize and certainly fund those types of treatments. It's not all doom and gloom, though. We have some silver linings, and we have some really good tailwinds going into 2024, one of which is around Humira biosimilars. And really the most funded drug in the United States, Humira, over the last decade or so, now has competition and alternatives that are safe and effective, and we're going to walk through some of those. But this is going to cause a very dramatic shift in terms of how we as a healthcare system have funded access to this drug Humira. And now we will see a reduction in allocation of resources to Humira and to some of these other products that do the same thing. All right, I do have some quiz questions. This being a webinar, you won't be able to shout out kind of your answer. So we'll have you kind of keep it in the back of your head what answer you came up with. And if you get it right, you can give yourself kind of a thumbs up. So what percentage of new specialty drugs are classified as specialty? So when the FDA is evaluating, they look at probably about 40 to 60 drugs every year that get approved and brought to market. What percentage of those actually get classified as these higher cost specialty drugs for rare disease states? And you can see the breakdown there. And the answer, hopefully you came up with one, is actually 80%. So 80% of the drugs getting approved by the FDA are higher cost specialty drugs. And that just continues to mean that there's a shift in that mix of drugs that come to market over to higher cost treatments. All right, and then my next quiz question for the group is, what social media platform made the use of Ozempic for weight loss go viral? Ozempic, which is not a medication that's approved for weight loss. That is a pleasant side effect for patients who have used that drug for treating type 2 diabetes. But due to a little bit of Hollywood and a little bit of viral marketing, we saw increased demand globally. Was it YouTube? Was it Facebook? Was it Instagram? Or was it TikTok? So kind of lock in your answer. Give yourself a nice pat on the back if you came up with TikTok. TikTok was the social media platform that really took this, and it caught wildfire and really spread that message that you have a drug now, which can cause significant reduction in a patient's weight, though Ozempic, the drug that often gets prescribed, is not FDA approved for that particular indication. All right, and then what anti-diabetic drug with that weight loss side effect has positive impacts on a patient's weight, is expected to post over 12.5 billion with a B sales going into 2023? Is it Mounjaro? Is it Wegovy? Is it the Ozempic that I'm sure you've heard that commercial a million times? Or is it Contrave? All right, so think about your answer, get it locked in. And it is that Ozempic, expected to have 12.5 billion in sales going into 2023. We're over halfway through. All right, so we're going to talk about Ozempic. We're going to talk about these GLP-1s. I'm not going to make it terribly clinical. I'm going to keep it pretty high level. My hope is that you can walk away from these with a little bit of an understanding of how the drugs work, really why they are doing the things that they're doing in patients' bodies. That way, as you get questions, particularly from maybe your members or maybe family members, you'll know a few things about these drugs that you can share with them. So these are medications that have been around for over a decade now. I remember as a pharmacy student working in pharmacy and having patients start on these. So they're a little bit over halfway through their life cycle in terms of patent protection. And we have lots of experience with them because we've been using them for a long time. The active ingredient, or the generic name, is semaglutide. It's in a class of drugs called glucagon-like peptide 1 receptor agonist. So basically, it's replicating in the body what this hormone, glucagon-like peptide, actually does. And that results in really 4 different functions. One is it increases insulin secretion. Your pancreas is what pushes insulin out. So it helps increase that secretion and really pressure the pancreas to do that. It decreases glucagon secretion. So glucagon is made in your liver, and it's really there to help you when your blood sugars get too low, or to make sure you have a little bit of blood sugar at all times for your brain, for your heart, just always kind of flowing through your bloodstream as energy. And so as glucagon enters into that bloodstream, it causes sugar to go into that bloodstream, and glucagon-like peptides actually decrease that from happening. It also slows down gastric emptying. This is a big part of what happens to impact weight loss. And then it actually signals to the brain as well to decrease appetite. And that by itself, if you're not hungry, it decreases caloric intake. And I don't want to scare you away. We're not going to go through this in exhausting detail, but sometimes it's good as you think about when you eat food, what happens in your body. And that kind of will tell you what these drugs do. They're just replicating something your body already does. So step one, you eat a cheeseburger. Before you ate that cheeseburger, your brain was telling you, I'm hungry. I need some food. I need some calories. My stomach is empty. I don't have food there. So give me some food. We need some energy. So you eat that cheeseburger in step one, that enters your stomach. When that happens, your stomach starts to fill up with food and it sits there for a little while. But eventually that food starts to move into your small intestine. There's a little valve at the bottom of your stomach, and that food starts to trickle through as it breaks down. It's got to be pretty small at that point, though. It's got to digest a little bit, because if it's too big, it can't actually go through that small little valve at the bottom of your stomach. When it hits your small intestine, though, so now your small intestine gets a little bit of food in it from your stomach, that's when you start seeing glucagon-like peptide 1 released, as well as this other hormone called GIP, which we'll talk about a little bit later. So when that GLP-1 and GIP get released, that hormone, it does a couple things. One is it signals to your stomach, hey, slow down. We don't want any more food coming into the small intestine yet. Don't move too fast. That really is because your stomach wants to sit there with all the stomach acid and break down that food, kill off any bacteria, keep you safe and healthy. And your small intestine is basically telling your stomach, hey, hold that food in there a little bit longer. But also when you have food in your stomach, I'm sure we've all been there at Thanksgiving dinner and we've overeaten. We don't want to keep telling our body, just keep packing food into that stomach. So it signals to your brain as well, this same hormone, GLP-1, hey, quit eating food, right? We've got food in the stomach. You're going to get too much food in the stomach, and that's going to cause a problem. We're going to be uncomfortable. So it also tells your brain to stop triggering appetite, right? Slow down that hunger drive. That slowdown in hunger drive is part of why we see weight loss in these patients. So food sits in your stomach longer, your brain tells yourself not to continue to eat food. Then, as I mentioned before, it's going to signal to your pancreas to start releasing some insulin so that it can move those calories from your intestine and from your bloodstream into the cells. And when we have diabetics, that's what they lack. They don't have insulin to help move that blood sugar from your bloodstream into your cells. And then the last thing is it's going to tell your liver, hey, we're getting calories from our small intestine. We're getting calories from food right now. We don't really need extra calories from the liver. So go ahead and stop sending that glucagon into the bloodstream, which is causing blood sugars to go up. So those are all things that work really well in managing diabetes, but they also have these impacts on weight because you result in caloric restriction. You just aren't eating as many calories because you're not as hungry. And the food that you do eat ends up sitting in your stomach and small intestine longer than it otherwise normally would. All right, if that didn't scare you away, then this slide I'm sure will. We're not going to go through this, but what I want to just highlight on it as a takeaway is we've got at least 5 different drugs that are in this class. There's lots of competition. We hear a ton about Ozempic because it's the most popular, but we have Victozas, we have Trulicities, we have drugs like Byetta and Bidurion. So we have competition. There's a lot of drugs that kind of do the same thing. They have slightly different requirements to how you give them and how they use them. But the biggest differences between these different drugs are whether you have to inject them every day or once a week. Some of them are daily, some of them are weekly. And then across all of them, they have to be refrigerated. They're not very stable. So if you keep them at room temperature, they tend to break down and they don't work as well. And then they come in pens. They are all injectables except for one drug called Rybelsus, but the vast majority are injectables. And those are pens or syringes. We do have one oral agent in Rybelsus that's on the market as well, though it's not quite as popular as some of the other ones. And then certainly Ozempic is the most popular. There's some additional benefits of these drugs that go even beyond diabetes and even beyond the impacts of weight loss. So we actually have 3 different drugs that are on the market. The Victoza and the Ozempic are included in this. And they've actually been shown to reduce the risk of cardiac events, things like heart attacks and strokes in patients who have type 2 diabetes and are at risk for those cardiac events. We already know that there's increased risk of heart attacks and strokes in patients with diabetes. So these are sometimes a good medication to choose if somebody has additional risk factors that could cause them to have a heart attack or stroke. That's not true with all medications that are used to treat diabetes, But certainly the GLP-1 drug class and drugs like Ozempic, sometimes they're a drug of choice. We actually want to pick them first line because they're going to provide additional benefit in reducing the risk that somebody could have a heart attack. And then just looking at how they're effective. And we'll start off just a little bit about how they work in diabetes. And then really we're going to focus our time on how they work in weight loss. So when we look at diabetes, we look at this impact on something called A1C, but that's a measurement of your blood sugar over the course of 3 months. The goal is a number of 7. That's where most diabetics want to be, is at 7 and below. If you're over 7, then you're not well controlled over that time period, about 3 months. And Ozempic, as you can see here from their data, it can lower that by about 2.1%. So somebody whose A1C might be at, say, 8.5, you can get them down to a 6.5. You can get them at goal with a single agent, that higher dose Ozempic for diabetes. And it's sustained. When you use that medication long term, this is a study that went up to 56 weeks, so over an entire year. It continues to maintain that reduction in A1C. So it's certainly a good drug when used for diabetes and helping those patients control their diabetes. When we look at their use in weight loss, the first slide that you see here on the left, or image, is showing you that you can see anywhere up to maybe about 14% reduction in somebody's body weight in those obese non-diabetic individuals. And that was with a drug, semaglutide. But you see that effect kind of across all of them. On the right side, you see Ozempic, which is a very popular drug. And this, instead of looking at the percentage of weight lost, it's just looking at straight pounds. How many pounds are coming off the body of these patients that are using these drugs in this way? And you're seeing with the Ozempic, particularly that higher dose, anywhere between 15-20, the 16.8 of weight loss. And I wanted to tee this up because we have a new drug that came to market last year called Mounjaro, which is a GLP-1, just like Ozempic, but it also has GIP components to it as well. And I mentioned that earlier, when you get food into your small intestine, it releases both GLP-1 and GIP. Because of that GIP component, you actually see improved weight loss up to 20 to 25 pounds as opposed to about 16 pounds. So we continue to innovate actually with how we use these drugs. And we're seeing even greater degrees of weight loss with some of these other treatments that have come to market. Adverse effects are common. The biggest one being nausea and vomiting. You can see here with Ozempic, particularly at the diabetic doses, 15 to 20% of patients have nausea vomiting. Slowing down the stomach, that whole process causes some of those gastrointestinal side effects. We don't necessarily see that with all the other diabetic agents that don't necessarily work in that same way. That's the biggest thing that we counsel patients on, is making them understand that using these drugs, the vast majority of patients are actually going to experience nausea and vomiting. This is the diabetic dosing. Once we start looking at the dosing that gets used in weight loss, which is about 3 times this amount, then we start seeing even higher rates in the 70 percentile of gastrointestinal side effects. And then I just want to highlight with the GLP versus GIP, just a little bit of differences and why maybe we're seeing some of those added benefits. One is that GIP component doesn't actually impact the gastric emptying, so slowing down how food exits out of your GI tract. But it does most of the other things. You actually have additional effects on weight loss, as well as increasing that insulin secretion. All right, and then the other thing just to keep in mind with these, there is a dose-dependent effect. So the more drug you give, the better the response you're going to have. Now, we always have to balance that, though, because as you turn up the volume on the dose of these drugs, you also end up increasing the side effects that can occur. And so while you're going to maximize weight loss at these higher doses, you're also going to decrease the tolerability. Patients just aren't going to be able to take it, especially long term, because it's just too hard on them from a side effect standpoint. But this study showed over this 20-week period, if you were on low dose of a drug, Victoza, you saw a weight loss of only about 6 kilograms or 15 pounds. And then when you're on the 3 milligram dose, that increased up to 8 to 9 kilograms, about 19 pounds that you could see. And so with these, as you get to those higher doses, you do see greater degrees of weight loss. There's another weight loss medication here on this slide that I want to point out. It's called Orlistat. That works differently. It's referred to as Ally on the market, or Xenical, you might have heard. It prevents the body from being able to absorb certain fats. Not as effective as these GLP-1s, which is part of why there's all this buzz around GLP-1s, is these are so much more effective than some of those other agents. Orlistat only saw about 5 kilograms of weight loss, and it had a whole different side effect profile. We got 5 different trials that kind of looked at these different drugs, because we have more than just GLP-1s to help with weight loss. We also have drugs like phentermine, that's a stimulant medication. You combine that with topiramate, and you saw up to 9 to 10% of weight loss with that combination. The good news about that combination of drugs for weight loss, it's very cheap. Phentermine's generic, it's been around for a long time. Topiramate's generic, it's been around for a long time. These drugs are pennies on the dollar. You then have the liraglutide, that's very expensive. It's one of the GLP-1s. The naltrexone bupropion is a little bit of the same story. It's inexpensive. They're 2 generics. You can take them separately. You see a little bit less response, maybe about 6 to 7%. Phentermine alone without the topiramate, a little bit of mixed results in the studies. In some cases, pretty low percentage of weight loss, and one of the studies showed actually pretty high percentage of weight loss. And then bariatric surgery, which is obviously very invasive, and really the last step that you would take, is the most effective, right? You see 28 to 32% of weight loss compared to baseline when you do bariatric surgery. But it's expensive, it has complications, and patients have to really go through a lot of preparation to qualify for bariatric surgery. And it's life-changing in 2 ways. It's life-changing to lose that weight if you are morbidly obese and don't really have another option to help reduce that weight. But it changes how you eat. It changes the medications that you can take. Since that's such a dramatic change in your gastrointestinal system, we don't typically see that until it's much further along and more like last line as a treatment modality. And then when we think about the use in diabetics versus weight loss, a few differences. So in diabetes, they were at lower doses, and they did not include diet and exercise as part of the component to evaluate how the drugs worked. The study populations were different. When you're trying to demonstrate that your drug works for diabetes, you select different patients than when you're trying to show that your drug works for weight loss. And then the dosing was very different. So lower doses for diabetes, much higher doses when you were using them for weight loss. The costs are different. So because you're giving more medication, it's more expensive. The manufacturers too, they figured that you would have a smaller patient population that would actually be able to fund and have access to the drug. And so they set it at a higher price point to make it worth their while. So as such, we see the weight loss version of these drugs sitting at about $4,000 more per patient per year compared to the diabetic versions of these drugs. And then the last big difference between the two is really around adverse event rates. So with Wegovy and Ozempic, these are the same active ingredient, but they are dosed differently. So when we looked at all of the gastrointestinal side effects, 73% of patients on that higher dose had those side effects compared to only 36% with Ozempic. Impacts on blood sugar occurred, but patients with that are overweight that are using these or obese and using these for weight loss, they had low blood sugars that could happen from taking the medication, about 6.2%. Retinal disorders, that refers to things that happen in your eyes. Mainly double vision can occur. We saw that higher rates at higher dosing, so 6.9% compared to 4.2%. A little bit concerning, we didn't see appendicitis in patients who were using these medications for diabetes, but about 0.5% of patients reported having it with the dosing used for weight loss. And then Ozempic face and butt. You may have heard this in the news too, or on social media. Patients who are using these drugs are losing weight at such a rapid rate that it's causing their face to sag and their butt to sag. It actually makes them look a little bit older than they did before they lost the weight. Those were not necessarily side effects reported in the studies. It's kind of happened now post-marketing.
Dr. Nate, we do have just one question in there.
Yeah.
when someone starts on these drugs, do they ever get off of them, or are they on them for life with just different doses? And I think maybe for this group, it might be helpful. Some of the participants are currently with MedOne and have excluded weight loss medications on their plan. And as we're planning for 2024, what are maybe some things that they should be aware of if they, wanted to cover the weight loss medications, what you're seeing within, what are some of the risks if we do cover those weight loss medications, or should we consider continuing to exclude them from the plan for many of them?
Yeah, thank you, Liz. Yeah, so as far as the question around the coverage parameters and what we're seeing across our book of business, a lot of clients are talking about it, right? They're evaluating whether or not this is something they want to add to their benefit, though they have concerns about the cost, and it's really driven by questions and demand from their employee base. That said, it's still very rare in the minority of cases where a self-funded employer group, especially one that we're managing, makes the decision to provide coverage and include coverage for these weight loss drugs. And it's for a few reasons. One reason speaks to the first question, which is once you start these, can you get off of them? You can get off of them, certainly, but you're unlikely to maintain the benefit of that medication long-term. So when you stop them, the vast majority of patients gain the weight back. The only ones that don't tend to gain the weight back is that minority of patients which needed some assistance to really just get them to their weight goal, but then they did the hard work to really change their lifestyle and behaviors so that they maintain that weight goal through diet and exercise. Unfortunately, these types of medications that help with weight loss sometimes get viewed as an easy button approach, and they're using them because diet and exercise are very difficult and don't necessarily work unless you're extremely disciplined in maintaining a rigid diet and exercise, particularly if somebody has, we'll just say, a genetic profile, which results in them really accumulating and storing calories different than somebody else. Some of this is not in the control of those patients. It's just how they're built, how they're wired. So part of the funding aspect that you do have to think about is if I do want to support my membership with access and funding to these treatments, am I prepared to do so long-term? Because using them short-term is likely not going to provide any long-term sustained benefit across those patients. The impact only occurs while you're using the treatment. When we think about the valuation, and this is kind of take this as Dr. Nate's opinion, this is supported by some evidence that I'll talk about, but my conclusion is that there's no silver bullet or easy answer to this. Do they work? Yes, absolutely. Are there side effects? Yes, absolutely. Some of which are severe. In fact, I just saw a class action lawsuit that's being prepared to go against Novo Nordisk, the manufacturer of Ozempic, because we're now seeing some case reports where patients stop taking the medication, and those gastrointestinal side effects that they had, the nausea, the vomiting, it didn't go away. And it hasn't gone away yet for those patients. We did not see that necessarily in the clinical trials or in the patients that I manage that are using it for diabetes. But given now just the increased use of the products, we might be seeing side effects that we hadn't seen before, and we've got these individual case reports. The last piece of that is not just about safety and effectiveness, but is it a good use of plan resource dollars? Is it a good value to pay for these drugs at the price that they cost set by the manufacturers? And thankfully, Dr. Nate doesn't have to answer that question, because we have another entity called ICER, that's the Institute of Clinical and Economic Review. That's a body of physicians that are independent, and they evaluate if drugs and other treatments are priced appropriately. That's their entire job, is putting out analyses around, is this drug or treatment priced right for the benefits that it achieves? They use a metric that they invented called the QALY, stands for Quality Adjusted Life Year. Just think of it as an independent metric that is evaluation. They would say that if it's $100,000 to provide somebody with a year of perfect health, that's what QALY means, then it's a good value, $100,000 or less. If it's more than $100,000, it's not a good value. It's priced inappropriately for the benefits that we would expect from that treatment. And you can see here that the semaglutide and the liraglutide, this is the Ozempics, Victozas, the Saxendas and Wegovy's are the name of those that get used for weight loss. Comparing that to just lifestyle modification, diet and exercise, they put a QALY of 234,000 and then over 500,000, which would indicate to me that ICER has concluded that these are a very poor value, a poor use of healthcare resource dollars at the price point they have for the benefits that they achieve. Compare that to the generics that are dirt cheap, phentermine, topiramate, bupropion, naltrexone, $9,000 and $45,000 respectively. That comes in well under the $100,000 QALY, and that would indicate that these are a good value for the outcomes that they achieve. And so when I look at that and I'm providing any kind of guidance to a group on how they want to think about covering these weight loss drugs, one of the things that I just ask them is, would you do it purely because you think it's a good use of healthcare resource dollars, or are you doing it for other reasons like recruitment, retainment strategy? And then the last thing that I'll mention on this is just that you don't necessarily have to go and get the manufactured product that's $16,000 per patient per year. There's also medical spas. There's even medical spas in the Iowa City, Cedar Rapids, and Waterloo corridor that will offer compounded semaglutide for a fraction of the price, $400 a month instead of $16,000 a year. So that's an option that's available today as people think about, hey, I really want to have access to this as a treatment. Sometimes the cash pay medical spa kind of area is coming in at a better price point because they can compound it and price it however they want to. You're not necessarily relying on the drug manufacturer to set a price on a commercial product. And thank you, Liz, for jumping in and letting me know the questions, because I actually cannot see them while I'm presenting. So if there's other questions, feel free to pop in and call them out. All right, I'm going to transition over to gene therapy, but keep the questions coming. We'll have some time at the end that I'm going to talk about or answer any of those questions, particularly if they're focused on the weight loss component. All right, we're going to keep this pretty high level too on gene therapy. It can be a very dense topic. And then for the sake of time, I'll go through it relatively quickly to make sure we have time to talk about Humira and the biosimilars that are coming out. So gene therapy is pretty neat. This is really the stuff of science fiction. I remember growing up and watching that movie Gattaca, and I feel like we're at the place where we're doing things kind of like that was in science fiction movies when I was a kid. Human gene therapy, this is manipulating your genomic sequence, right? That code that drives all the different biologic processes, the proteins and whatnot that your body makes to have it function. It alters those genes in living cells to create some sort of therapeutic use. And there's really two characteristics that any gene therapy has to have. One is it has to have an active substance that regulates, repairs, replaces, adds, or deletes a genetic sequence. You know, it's not gene therapy if you're not changing the genes themselves. And then whatever its effect, when you change those genes, you're focused on a therapeutic, preventative, or diagnostic effect related to what sequence of gene code, that's referred to as this recombinant nucleic acid, that you inserted into that cell. There's two types. There's germline and somatic. And we'll talk about those a little bit as well. Gene therapy history. We're going to talk about a few of these landmarks, but this dates back to 1928 when Frederick Griffith described this thing called the transforming principle. We'll do a little bit of a discussion around that. Continued, we kind of understood that there was something there related to genes and started to understand genes in 28, but we didn't even know what DNA was until 1953 when Watson and Crick described the structure of the double helix DNA. A couple of Nobel Prize winning chemists identifying that structure. As we kind of move forward here on the timeline, and again, you can read this, we'll send this out as a resource. We then saw from 1953 then up to 1990, the first therapeutic gene transfer in patients. 1999 was a pausing point. We had a death of Jesse Geisinger. That was the first time somebody was in a trial for gene therapy and died, and actually died quite quickly. 2003 was the first time that a gene therapy was approved in the world, and it was done in China. And then starting in 2012, we started to see recommendations for therapy products in the European Union. It wasn't really until about 2017 that we started to see those products in the United States. All right, so Griffith's experiment involved, and this is back in 1928, the first time that we started to understand, and he described that there's something that can be transferred between animals. And in this case, it was mice. And so if you remember your high school or college biology class, this will be a little bit of a refresher. Basically, he was giving mice these living smooth cells. These smooth cells were causing those mice to die. So if you gave them a bacteria, that bacteria killed the mouse. He then took those same smooth cells and identified and isolated. There was some that actually had rough edges on them. He then gave that mouse those rough cells, and the mouse remained healthy. So if it was a smooth bacteria, it died. But if it was a rough bacteria cell, then it survived. He then took the smooth cells, and these ones should kill mice. He heated it up, that killed all the bacteria, gave it to the mice, and the mice lived. They did not die, which makes sense. You kill the bacteria, and that's not going to then harm the mice. They didn't know that back then, but we know it now, of course. And then they took the heat-killed smooth cells. He mixed them with living R cells, right? And those living R cells were the ones that were rough, that did not kill the mice. They remained healthy. And what he was trying to figure out is there anything from those dead smooth cells that could be transferred over to the rough cells that would kill the mouse? And his hypothesis was no, of course not. You're taking two things that don't kill mice, mixing them together. Why would it kill a mouse? But he was surprised to find that it did kill the mice. He isolated it out, and he found living versions of those smooth cells. So something got transferred from a dead smooth cell to a rough cell and actually transformed it. It turned a rough cell into a smooth cell. And that's how we started to understand that, hey, there's this genetic material that can actually go between bacteria, and that can actually transform it. It can make it into something different. It used to be smooth, and now it's rough. 44 is when Oswald Avery published the landmark literature theory around hereditary units. This is when we define genes and define DNA. And then, like I said, in 53, Watson and Crick actually developed the structure of DNA. But this is genetic code as we know today that can be transferred between animals and between cells. And it codes for the biologic processes that our bodies have. In 61, Temin actually showed that genetic mutations can be inherited by a virus infection. And when we think, we're going to talk a little bit about viruses as vectors, but viruses are very important in terms of being able to get into the part of the cell called the nucleus that contains the DNA. Tatum in 66 described that you could actually use viruses in somatic cell genetics to develop gene therapies. Now, while he described how you might do it, we didn't have the technology to actually try it out until really the 1980s. In 1973, it was actually really the first direct human gene therapy trial. There were two girls that were suffering from this condition called urea cyclic disorder that causes ammonia to build up, which results in neurologic injury. Basically, these are developmentally delayed individuals. Their brains won't develop and function the way that they should. And what's causing that is that they don't actually produce this enzyme that breaks down ammonia. And so he found a bacteria that produces that same enzyme and thought, hey, if I give that bacteria to these girls, maybe it'll go into their cell through the papillomavirus and correct that gene. It was not engineered. It was just wild virus that was out there. Unfortunately, it was negative. The gene that was used actually was not the right one to make the right enzyme, but it was the first documented gene therapy trial. Fast forward to 1990, Martin Klein becomes the first to attempt gene therapy with this new technology, recombinant DNA. He did this without approval from an international review board. He actually got denied. International review boards look at trials that scientists want to do. They determine whether or not it's ethical and safe. The International Review Board said, no, this is not ethical or safe. Martin Klein decided to do it anyways. He engineered the DNA. That was what was very new. Is before in the 1970s, right? They were just using what was already in the virus. In this case, he actually made it. He made the gene he wanted to insert. He was looking at a condition called beta thalassemia, patients who can't make hemoglobin. And again, the outcome was negative. It did not work in these patients, but it was the first time that we engineered DNA to administer to a patient. 99, as I mentioned, Jesse Gelsinger died. He received a gene therapy as part of a trial, and the virus that was administered, he just reacted very strongly to, passed away a few minutes after receiving his infusion. And it really, in the United States, put a halt and a stop to studies and trials around gene therapy. We really started to look at whether or not this was safe to do and what are ways we can do it safer. Doesn't mean that same thing happened in other countries. Not overly surprised, given the regulation or lack thereof that can occur in China, that gendesine was the first gene therapy approved and used in the world that is a gene therapy. It's an interesting drug. You give it, it's used for cancer, and it actually goes into those cells. It changes the genes and it codes that cell to basically destroy itself, which is what you want to do in cancer, right? You want to destroy the cells that are producing more than they should and causing tumors to occur. This was in neck and head cancers. That said, it's never been approved in the US. It's only approved in China, this particular treatment. 2012 was a big year, not just because it's when I graduated pharmacy school, but CRISPR gene editing technique was published. CRISPR, you may have heard in certain articles or scientific literature. What CRISPR does that's different than anything before it is it allowed a very cheap, inexpensive way to create DNA that you want to insert into a cell. And it also allowed you to insert it precisely at the exact place you want it. Prior to CRISPR, you didn't have a way of putting that gene exactly where you wanted it in a cell. It also made it cheap. It made it so that it wasn't as expensive to create these genes and insert them into cells. So there's a reason why in the last 10 years, we've started to see an increase in development of gene therapies. Prior to 10 years ago, we didn't have CRISPR, and that meant that it was very expensive and very imprecise, so not very effective to develop gene therapy treatments. After CRISPR, now it's much easier to develop these treatments. And we can also be very precise in where we're putting those genes where they need to be. And then 2017, as I mentioned, this is when the first gene therapy was approved. This is Lexturna. It treats blindness due to this condition called Leber's congenital amaurosis. It's expensive at $850,000 for both eyes, very rare condition. So when it hit the market, it didn't necessarily cause as much of a buzz as what we saw with drugs like Zolgensma because of the price point and really the rarity of the condition. And as we look at 2019, that's when I think probably most managed care entities like MedOne, PBMs, certainly employers that are funding benefits, and then the healthcare community at large really responded to the approval of Zolgensma, the first drug approved over $2 million to manage a patient. One-time cost, changes the genes in these patients with spinal muscular atrophy, and maybe a cure. It may be something that allows them to live long into adulthood. But as we look through the history of gene therapy trials, this goes through, kind of shows what all of them are and where the investment has been in trying to find treatments. The vast majority, which is a little surprising because it's not like we have a ton of treatments for cancer that are gene therapies, but the number one treatment for gene therapy research or area for gene therapy research is cancer diseases, almost 1,200 trials going on. And then we've got monogenic diseases at 161. That's a huge fall off, of course, only 9%. And that's where you have one gene involved. That's what monogenic means. Only one gene you have to fix. Then it goes down to cardiovascular, infectious, neurologic. But we're looking at different ways to use this technology to manage certain disease states. But cancer is the predominant one that's being researched today. There's two different types. There's in vivo. That's where you actually give the patient that gene therapy through an infusion. It enters the patient's cells and it changes it to produce some sort of protein that they couldn't produce before. Classic example is that Zolgensma. There's also something called ex vivo, and you might have heard of CAR T therapeutics for cancers. And this is actually where a patient would donate their cells, send them off to a lab somewhere. That lab would re-engineer those cells outside of the patient's body and then give it back to the patient to be re-administered into their body. That's what ex vivo means. And there's both kinds. So we see treatments that are just kind of infusions, and then we see treatments that are also ones that you actually give your cells to somebody, they change it, and then administered back to you.
Dr.
Liz, I
Nate,
see you
are
popped on.
these actual cures, or are they just maintenance treatments for these gene therapies that are being developed? And I do want to be cognizant on time that we just have about 10 minutes left. And so again, as you know, these clients are considering changes or exclusions or what they should cover or not cover for their members in 2024, maybe more recommendations on what gene therapies are coming to the market and maybe why we would want to be aware of those would be helpful.
Yep, absolutely. So they're both. They can be cures, but they can also be, I shouldn't say maintenance treatments, because we don't know about redosing, but we do know with certain gene therapies that the effect falls off over time. Some of them are cures, one and done. That patient is going to no longer have that condition long term. But we do have some, one of the new ones that has come to market for hemophilia B. We know that over the course of about 8 years, that gene therapy loses its effectiveness. And then you're left with a big question mark. What do you do at that point? We don't know yet if you can redose these patients again after that effectiveness falls off. Really, there's a couple options from a plan design standpoint. Right now for 2024, we're expecting probably something north of 10 new FDA approvals in gene therapy. In 2025, that's going to fall back off. We'll see it go down to maybe about 5, and then we'll probably always see about 5 or so for the foreseeable future. It's a lot of research, but for whatever reason, 2024 is going to be a pretty hot year when we look at the pipeline. FDA is evaluating somewhere more around 20 of them. I don't think all of them are going to get approved, but there's probably going to be at least 10 of them that do get approved going into next year. And then the pipeline falls off, but I think it'll always stay at probably about 5 or so that are getting approved each year. I'm going to, as far as, I'm going to skip some of these slides because I want to talk about Humira with our remaining time. But as far as plan design considerations, the most defensive is just putting in a gene therapy exclusion. A lot of our plans do that. These manufacturers and these patients have other means in terms of getting access to $2–3.5 million drugs that could be outside of the prescription benefit. You can imagine patients aren't going to be able to afford that on their own, and there are safety net programs in place to help them. So I would say even in our block of business, at MedOne, we do see a majority of plans as a defensive strategy choosing to exclude those. Those that do exclude them, or that do include them, I should say, really work towards having value-based contracts in place. And what that means is that rather than paying $2.5 million up front, you pay an initial payment, maybe $500,000 for that initial treatment. And then the patient actually has to demonstrate certain responses and certain benchmarks in terms of the drug working. And then they would be invoiced for additional payment. So you might, over the course of that 8 years, have $250,000 that you're paying every year if the patient's still responding to treatment. Once they stop responding to treatment, then you no longer are responsible for making those payments. So value-based contracting is really big in gene therapy when it's covered. When it's not covered, it's those safety net programs that come into support. And again, I will send this to you. You will have these slides that you can reference, and feel free to reach out to me if you have any questions. The last one is just about biosimilars, and we've got about 6 minutes left, and I'll make sure we end right on time. The difference here is that some drugs are biologic substances and other ones are just chemical compounds, and that's really the difference. Biosimilars refer to those generic-like products when you're working with biologic substances. When it's a chemical compound, then it's a generic drug, it's less complex, and you can make an exact copy of it. With biosimilars and biologic drugs, it's really hard to make a copy, an exact copy of it. because the way that you synthesize that biologic substance does not ever get released by the original manufacturer. But you can be close. You can be really close. And in terms of the FDA, close enough that it doesn't matter in terms of whether it's just as safe or just as effective. Biosimilars, they're generally made from living sources as opposed to generic drugs that are made from chemicals. Biologic drugs require special processing to produce. Generics are relatively simple to produce, which is why they're so cheap. Biosimilars are nearly identical, and in terms of how our body responds to them, they're going to respond to them in the same way. But generics are an exact copy of the named drug. They're both faster to develop than a new drug, right? So if you're trying to make a new drug that doesn't exist, that takes a long time and is very expensive. But both of these can be made faster and more cheaply. And then they're less expensive to make than the original biologic. And then generics are less expensive than the brand name, of course. And then you can see here that a biologic can take 15 years to develop versus the biosimilar is less time. When a manufacturer is making a new biologic drug, it can be $1.2 billion compared to only 100 to 200 million. And then when it's a biosimilar, it's not patentable, right? At this point, the drug is off patent. There's competition, which drives pricing down. And then with Humira, this is that drug that was widely funded for the last 10 years. In fact, AbbVie, the manufacturer, made more on Humira than Southwest Airlines made as a business, as an entire airline prior to COVID, let alone after COVID. So they've kind of had a lock on this market. There's been high demand and high use of this drug, and it's not a bad drug. It's just expensive and highly utilized. Now, because of regulatory changes that started in 2012 with the ACA, we have competitive market or competitive drugs, these biosimilars that have entered the market. The first one was Amjevita. We saw a 30.9% price reduction in comparison. And then more recently in July, we saw drugs like Yusimry and Hadlima hit the market, which have closer to an 80 to 90% price reduction compared to Humira. Now, these are just as safe, just as effective. They actually had to submit clinical trials to get brought to market that show that it works just as well as Humira and has a similar safety profile. Yusimry is the one that on MedOne side, we've identified as the most cost-effective biosimilar for Humira. Part of that is because of partnerships with the drug manufacturer Coherus. They're working with Mark Cuban's Cost Plus Pharmacy. They're working with MedOne Pharmacy Services as well to provide this drug north of an 85% discount. So Humira right now has a list price north of $8,000 per box, and one box would typically manage a patient for a month. They also provide a rebate. There's a pharmacy discount. Most insured employers and insured members, then total cost of that treatment comes in at just around $5,000 per patient per month. What Yusimry did in Coherus is they came in at a price point. Their list price is $1,100. Pharmacies are buying it just a little bit under $1,000. And then pharmacies like Cost Plus and MedOne Pharmacy Services can buy it even less than that. I think the Mark Cuban price, there was a big press release back in June. He's buying it at $565 plus shipping plus dispensing fee. So this is a real shift in the market. When we think about that need for those patients that need Humira to control their disease states, rather than having a drug that you have to pay $5,000 a month for, we now have drugs that are coming in south of $700 that do the same thing and have the same active ingredient. That'll have a real dramatic impact on the overall market and the price point that we're seeing these treatments come in at. And so while I talked about some things that are driving cost up, the most expensive and most funded drug in the US is now seeing the floor taken out from under them and price reductions north of 85%, which we'll see across the market. All right, we're at 2:59. I'm going to pass it back over to John to wrap us up.
Hey, Nate, Dr. Nate, I was wondering, employers are used to when a generic comes out that the employee is now required to take the generic, or there's a significant penalty to not take the generic. So would you say, but we're also used to multiple brand names being treated for the same condition. Would you say these biosimilars are more closely aligned with, hey, there's a brand name, look at this as a generic, or is this more aligned with, hey, here's a brand name that treats X condition, here's another brand name that treats X condition? Which would it be closer to?
Yeah, it's closer to when like a generic comes out.
Okay.
Though, if you're looking at that as like a 0 to 10 scale, it's like a 2 on that scale, meaning it's a little like a brand and another brand, and that's more of how they get approved. But in terms of how we think about them at MedOne,